All right, this is a continuation. So we know already that the alkenes and the alkynes are hydrocarbons that have a double or triple bond in it. And a couple things to remember here is that the that the parent chain is the longest chain that includes the double or triple bond. Carbons are numbered starting at the end closest to the double or triple bond. And what we have to do is indicate where the double or triple bond is in the parent chain, and we do that using a number. And we still name side chains the same way as we do in the alkanes, and we use the prefix "ene" and "ine." So we're going to take a look at the ball and stick model, structural diagram, condensed structural diagram, line structure, expanded molecular formula, and molecular formula, and what they look like for a hydrocarbon that has a double or a triple bond. So if we look at our example, right up here at the top, we notice very quickly that we have a double bond right here. So they're sharing 4 electrons. So what that means is that we have to name this in a way that we indicate the position of the double bond. And a little side note here, we always number our carbons so that the double or triple bond has the lowest numbered carbon possible. So what that means is we're going to name this carbon 1, 2, this is going to be 3, 4, 5, 6. So we know that this is a hex. So we know this is a hex because it has 6 carbons. And then what we do is we indicate the position of the double bond by putting in a 2. And then it gets the ending "ene." So hex 2 ene. So there are 6 carbons. Oh, sorry, no, I lied. This is a 1. Sorry, my daughter distracted me. So this is hex 1 ene. Okay, so we have to indicate the position of the double bond, but we only have to indicate where the double bond starts. We don't have to say, we don't have to indicate both carbons involved in the double bond. Okay, so our structural diagram, this is fairly straightforward. It's going to look like this. Okay, and the one thing I want you to note is that those 2 hydrogens on the end of carbon 1, they have that trigonal planar shape because there's only 3 things bonded to that carbon. So we just need to remember our molecular geometry on this one. Our condensed structural diagram will look like this. And then our line structure will look like this. 1, 2, 3, 4, 5, 6. Then you just draw another line here to indicate the double bond. Expanded molecular formula looks like this. And the molecular formula looks like this. Okay, so what I'd like you to do now, actually first, sorry, we'll name our next one. So we look over here at our next example. We have something that has 4 carbons and it has a triple bond right in the middle. So 1, 2, 3, 4. So this is bute for 4 carbons, 2 ine. Okay. So what I want you to do is hit pause. I want you to draw the structural diagram, condensed structural diagram, align structure, expanded, and molecular formula for this structure right here. Then hit unpause and check your work. Okay, so we have those here, and then we have to come down here. We'll go into the parent chain. It's looking at this, it's pretty obvious that we're going to number our parent chain 1, 2, 3, and then we have to figure out which way to go. So we're going to go, it's either going to be 4, 5, 6, 4, 5, 6, or 4, 5. So I think we'll continue and go just 4, 5, 6. And so we'll name our parent first. This is going to be hex. Our double bond is on 2, ene, but we have 2 ethyl groups. So we have to indicate that those exist. They're on carbon 3 and carbon 4. So this becomes 3,4-diethyl hex 2-ene. All right, so let's look at our next example. So in our next example, we have 1, 2, 3, 4, 5, and then it doesn't really matter which way we go. It's going to be a 6. So this is going to be a hex again. And we have to number our carbons to give it the lowest possible number, the double bond. So I think it means we're going to go this way. 1, 2, 3, 4, 5, 6. So our double bond starts on 3, so hexene. And we have 2 methyl groups bonded here. So we go 2, 2, dimethyl. All right, so let's name our last example. So this has 8 carbons, so it's an oct. The triple bond starts on carbon number 2, and there's an ethyl group coming off of carbon number 6. So the name for this is 6-ethyl for this. And then the 2-ine right here, and then our 8 carbons. Okay, so don't need to worry about this section here, but what we do need to do is draw a couple. Now, drawing is actually significantly easier than naming because you can just do it in steps. So pent, here we have 5. So you're going to draw your parent chain, 2, 3, 4, 5. You have a double bond on carbon 2, so that's going to go here. And you also have a methyl on carbon 2, so CH3, and then you finish by filling everything up with hydrogens. So that needs hydrogen. So the secret to drawing these is to just draw the parent chain first, add in your double bonds or your triple bonds. All right, so we look at our next example. Our parent chain is hept. So this means that we are going to have 7 carbons. 1, 2, 3, 4, 5, 6, 7. We have a double bond at carbon 3. So right here. And then we have a lot of side chains. So we have 2,2-dimethyl, so 2 methyl groups on carbon 2. And then it looks like a ethyl group on carbon 3. So once you've done that, saturate everybody with hydrogens. All right, our next one, hept. again for 7. So 1, 2, 3, 4, 5, 6, 7. 2 ene, so a double bond at 2. Looks like we have a propyl group on carbon 3. So 3 carbons. 1, 2, 3. And then saturate it with hydrogens. Now, I want you to note that I'm underlining things as I add them to the molecule. That helps me make sure that I don't miss anything, because once every section is underlined, I know that I'm done drawing. So I'm just going to be lazy and put dashes where my hydrogens would go. You would never be this lazy because you want full communication marks. So you would actually draw in your H's. Okay, I'm going to do one more, and then I'm going to hit pause and ask you to try the next 4 on your own, and then unpause and check your work. So our last one we're going to do, there's our common hex again. 6, 3, 4, 5, 6. Our double bond is a 1 ene, so right here. And then we have a 4 ethyl, so on carbon 4, a ethyl group, and a 4, 5, it's the wrong color, a 4, 5, so 2 dimethyl, so a methyl group on carbon 4, and a methyl group on carbon 5. Again, everything's underlined, which means I have all the parts I need for this molecule. Okay, so that's what our finished molecule is going to look like. All right, so 4 more to go. Oh, oops. 4 more to go here, if I can find the page back. There we go. I want you to hit pause and try to draw these 4 and then check your work after. Okay, so here are those 4 alkenes drawn based on their names. Just do a quick check to make sure you've done them correctly. And then you have some practice to work on. After you work, go through the next video lesson where you're going to look at cyclic hydrocarbons.